Hello, my name is Filip Knapik and I'm a product manager for Cloud Composer. In this quick tutorial, I'm going to walk you through what we consider best practices for Cloud Composer around July 2022. In the future, we may need to upload another video as we launch new features and our best practices evolve. Let's stick to it for now. I'm going to start with versioning, starting from Airflow versions. There are two main lines of Airflow versions, Airflow 1 and Airflow 2. Airflow 1 is not really supported or not really developed anymore by the Airflow community since December 2020, because at that time Airflow 2 got introduced and the entire attention of the community has shifted over to it. But Airflow 2 is superior to Airflow 1 from, practically speaking, all the possible angles. It has much better scheduling performance, ability to run multiple schedulers, which translates into better reliability of your DAG runs, stable REST API and no longer experimental API that Airflow 1 came with, refreshed user interface, which is not only more pleasant to look at, but also much more efficient to use on a daily basis, task groups, task flow API, provider packages, and so on and so forth. Put differently, Airflow 2 is significantly better from performance, reliability, and ease of use perspective than Airflow 1. And it also is much more future-proof. Therefore, I would highly recommend starting with Airflow 2 if you're starting your adventure with Airflow and Composer right now. And if you have any existing Airflow 1 deployments, to immediately plan for an upgrade to Airflow 2. Once you are using Airflow 2, you can benefit from Cloud Composer 2 capabilities that we have launched. Cloud Composer 2 is a new line within the Composer product, and it comes with multiple improvements on top of what Cloud Composer 1 offered. First of all, it comes with auto-scaling, so the environments can expand or shrink, or more specifically, to add more workers or remove workers as needed, depending on the number of tasks that it has to handle at a point in time, which translates into either better performance of your DAG runs or a lower cost, because you don't have to size your environment for the peak. You can let the environment to expand as needed following your demand. It comes with new user interface. There is a simplified environment creation workflow and also much more efficient and easy to understand monitoring tab of the environment, which simplifies any potential troubleshooting. There is a new pricing model available in Composer 2, which includes most of the significant components of the environment under a single unified pricing model, which simplifies total cost of ownership understanding. To be more specific, in Composer 1, the compute layer of the environment, the virtual machines, were part of the compute engine pricing model and cost model, which meant that Composer environments were translating into a cost of Composer and compute engine. In Composer 2, this is no longer the case because all of the compute components are now included into a single pricing model, so you have full understanding of the charges associated with your Composer 2 environments. Composer 2 comes with simplified private IP networking because we allow not only VPC peerings, but also private service connect, which is a new connectivity method that simplifies creation of environments. There are less IP ranges that are needed to be provided in private IP environments, and also no risks of hitting VPC peering limits as opposed to what happened in Composer 1, which is a significant simplification of networking. Last but not least, Composer 2 comes with disaster recovery support through environment snapshot feature. So these are all the reasons why I would highly recommend starting directly with Composer 2 and jumping over Composer 1. There is nothing you would lose by doing that. There is no feature that is missing here that Composer 1 provided that would make you select Composer 1 over Composer 2. Let me move to another topic, which is how do we manage environment lifecycle? Most of our customers use some form of configuration as code, and vast majority of them use Terraform to manage their environments, to get them created, get them updated. And this is what I would highly recommend, seeing how customers benefit from infrastructure as code deployments and how they manage the fleet of Composer environments in a centralized way using code. This is what I would highly recommend, and there are going to be links provided below that video to all the resources I'm referring to. And in this specific case, I'll provide a link to Cloud Composer package in Terraform that allows you to manage your environments using Terraform provider for Cloud Composer. A common and general good development practice is to have multiple stages of your environment. Obviously, not only production, but also some form of test and some form of development. And obviously, this is also something I would recommend for Composer environments. You would ideally go for free, again, test, development, and production, or at least to obviously not going with production only. One thing I'd like to call out is that we're currently working on local development support that will allow you to run Composer-like environments on your own machine, which may act as a development environment outside of Cloud Composer. And at that point, you would just stay with test and production environments directly in Cloud Composer while the development would be running on your machine. That's coming late in 2022. In either case, I highly recommend to have 3 stages and test all of the changes of your DAGS and configuration settings in lower level environments before pushing them to production. When it comes to service accounts, by default, you would go for Compute Engine service account, but it's not something I would recommend. Instead, what I would recommend is to create specific service accounts tailored to your needs with specific roles and use those for Composer environments. This way, you don't grant more permissions than needed to your Composer environments and to your DAG runs at the same time. So again, I would recommend first creating a service account with proper permissions, proper roles, and then using those service accounts in Cloud Composer environments as opposed to the default Compute Engine service account. A good practice from an operations perspective is to get notified whenever things don't work as planned. Starting with DAG runs, we would like to get notified whenever we have failed DAG runs in production. The way to do it is to use cloud monitoring and specifically alerting policies and notification channels available in cloud monitoring that will automatically trigger email notifications to your inbox whenever a DAG run fails. There is a way to do it without any changes in your DAG source code, simply by configuring cloud monitoring. I will provide the link to a separate tutorial that talks exactly how to get it done below that video. So please follow that if you want to get automatic email notification on DAG run failures. Another element you may want to be notified on are any issues with crucial health metrics of the environment itself, like for example, environment health, or maybe some CPU metrics of the environment, and so on and so forth. One thing I'd like to call out is that under the monitoring tab of Cloud Console for Cloud Composer, you have those bell icons. If you click on those, you will immediately be moved to a proper page in Cloud Console where you can configure an alert for that specific metric you're seeing here. So for example, if I clicked that, I would be transferred to a place where I can set up a notification on environment health metric and essentially get notified whenever it is unhealthy in this specific example. So I highly recommend using that as well on top of DAG run failure notifications so that you can get notified on any issues that are taking place at the environment level. For more advanced customers or customers having multiple environments, you may also consider creating some form of a dashboard that spans across multiple Cloud Composer environments or even multiple cloud projects with Composer environments. So you can actually create a single dashboard that captures crucial information from multiple projects and multiple Composer environments and have a single pane of glass through which you're looking into the fleet of your Composer environments. If, for example, you're part of a platform team internally within a company providing Composer as a service to other teams. There are some ways to do it directly within cloud monitoring. You can create a dashboard that captures such information and presents them in a single place. I'm going to also provide some links to tutorials on how this could be done on your site. So again, if you have multiple environments that you're managing centrally within your organization, you may want to create a centralized dashboard across projects and environments at the same time. Important item to call out when it comes to proper management of Composer environments are maintenance windows. Since we're managing the infrastructure, this is a fully managed service, we need to from time to time apply some patches and updates to underlying components to improve the security, reliability, and so on and so forth. You have control over when this maintenance may happen, and I highly recommend that you set this time to those periods in your business life cycle where you have less DAG run activity or less critical DAG runs taking place. So you have a feature called maintenance windows, which you can control through user interface or other API surfaces, and you can configure when would you like to have maintenance windows executed. Now, there are a couple of things to call out when it comes to the importance and meaning of maintenance windows to our environments. So first of all, on average, so far, we see that maintenance happens around every 3 weeks. So just for your benchmarking and understanding how frequent this might happen, this is so far the frequency the maintenance is applied to your environments. That's obviously not a guarantee that it's going to stay this way, but that's the typical cadence. Composer environments are continuously available during maintenance windows. There is no downtime. It's not like the environment is going to stop responding to your requests or you're not going to have anything running during that time. This is not what maintenance windows mean. What actually might happen though is that some components of the environment may get restarted during maintenance windows. And as they get restarted, it can also mean that individual tasks may need to be marked as failed, because if a worker gets restarted and the task was running in a worker, then obviously a loss or a restart of a worker means restart of a task or a failed task, to be more specific. So first of all, setting task retries to a value greater than 0 is definitely the right way to mitigate the impact of those activities, but also switching to Composer 2 is another way to mitigate that impact, because in Composer 2 we can guarantee that tasks taking up to 55 minutes will not be affected by maintenance windows. In other words, if a task takes up to 55 minutes, we're going to take some steps not to impact this task, even if it's exactly during the maintenance window and we do want to restart a worker. We can actually prolong the maintenance and wait for up to 55 minutes for those tasks to complete. If a task takes longer than 55 minutes in Composer 2, they may get restarted, and this is again where retries higher than 0 would help. In Composer 1, there is no such guarantee, and tasks of any duration may get affected by maintenance windows. Another thing I would highly recommend is to automate DAG deployments. The interface to upload your DAGs in Composer is through a storage bucket. Now, this is a great way to do it as you're starting your adventure with Composer, as you're starting the development, but in a production environment, you would typically establish automated CI/CD pipeline from whatever source control repository you're using into Cloud Composer. And that's exactly what I would recommend, to have some form of CI/CD pipeline with built-in testing and pushing of the code of your DAGs to environments when they are ready. There's going to be also some tutorial and links on how to get it done lower in the comments. From time to time, you need to upgrade your environments to get access to newer features and improvements of the service. We recommend that you upgrade your Composer environments between 3 to 6 months, or generally no longer than that, but definitely not longer than every 12 months. Every version of Cloud Composer environment is fully supported for 12 months from their launch, and then have some crucial fixes and updates performed in the next 6 months, so until 18 months, for example, for security updates and so on and so forth. To get full support, again, you need to upgrade not less frequently than every 12 months, but we highly recommend that you keep this cadence to every 3 to 6 months. There is a feature to upgrade environments in place, so you don't need to delete your environments and create new ones and move over this way. You can simply upgrade in place using a built-in upgrade feature of Composer environments. When it comes to environment sizing, and specifically focusing on Composer 2, there are some high-level rules on where you would start in terms of environment presets. In Composer 2, when you create a new environment, you have those presets available in the user interface, where you can pick that the environment is small, medium, or large. And there's also a custom option for more advanced customers. If you're wondering which one to go for, these values could be somewhat helpful in figuring it out what is the right starting point. Vast majority of cases where people just start are fine to proceed with small environments, and you can change all of those settings as you move on, as you add more DAGs or increase their frequency. So typically small is the way to go, unless you already know that you have, for example, thousands of DAGs that you need to run in the same environment with high level of concurrency. At that time, you may need to go to higher environments right away. In either case, whichever of those you pick, there is a guide on how to tune the environment and what elements to look into, trying to get to an optimal performance cost ratio in your environments. So please start with any of those presets using this guideline that you're seeing right now, but then use the guide that I'm also going to link below to tune the environment further and either reduce your cost or improve performance or reliability of your DAG runs. And remember that Composer 2 comes with auto-scaling, so please use that feature and set your worker ranges in a way that you allow the environment to grow and shrink. In other words, don't go for workers between 3 and 3, instead of go for workers between 1 and, for example, 10, and allow the environment to expand as needed, as this provides optimal performance and cost. In private IP environments, use Private Service Connect. This is the right way to connect between different components of Composer environments instead of using VPC peerings. So this feature is available in GA, and it simplifies networking setup, and it also reduces the consumption of VPC peerings, which for some customers has been troublesome because the number of VPC peerings in a project or in a network is limited. So again, highly recommend to use Private Service Connect whenever you're creating private IP environments in Composer 2. When it comes to connections and secrets, use different connections for different dev, test, and prod endpoints. So the source code of your DAG could be exactly the same regardless of the stage you're in, but then the connections would be different and they would dictate which endpoints those DAGs interact with in each of those stages. But one thing to call out very, very clearly is that you should never put passwords into connections, as this is not the right way to do it, not the recommended way to do it from a security perspective. The proper way is to use Secret Manager and store your secrets there and automatically pull them into your DAGs using an integration between Cloud Composer and Secret Manager. This is also a part of the activity that I'm going to be linking tutorials for lower in the comments of this video. So again, please use Secret Manager and its integration with Composer to manage your secrets there instead of putting your secrets or passwords into connections or variables, because they are not safe if you do it this way. When you're coding your DAGs, please use task retries wherever possible. So don't set your retries to 0, because there's always a risk that something goes wrong in the environment and your entire DAG run is going to be marked as failed if your task retries are set to 0. I understand that there could be some special cases where you don't want to retry tasks, but please ask yourself whether this is really the case when you set it this way, and definitely don't go for that as a default. In general, tasks may need to be retried in specific circumstances because of networking setup or whatever else, and this improves reliability of your DAG runs to keep retries higher than 0. For CPU or memory heavy tasks, you may consider using Kubernetes pod operator, and this way move those heavy workloads away from shared workers, because if you run too heavy of a task in a shared salary worker, you may impact the stability of the worker altogether, which will in turn impact the tasks which were running in that worker at the same time. So in other words, an unstable worker has implications to other tasks running in the same worker. Therefore, if you have those heavy tasks, to keep them separate from shared salary workers, you may consider putting them into the Kubernetes pod operator. Now, if you have many DAGs, one thing I would call out, because I've seen many people struggling with it, is to increase parsing interval, which is a specific configuration of Airflow, which tells scheduler how frequently it needs to look for changes in your DAGs. Why is that important? Because scheduler processes your DAGs in an endless loop with a specific interval, and it tries to see whether there are changes, notable changes in your DAGs that it needs to reflect in the serialized form of those DAGs within Airflow itself. Now, the moment you have many DAGs, it pushes the scheduler or DAG processor to process all of those DAGs very, very frequently. Imagine that you have the default of the interval, for example, set to 30 seconds, but because of how many DAGs you have, it takes Airflow, let's say 1 minute, to go through all of those 1000 DAGs and make sense out of them. Now, if you have set it to 30 seconds, but it's heavy enough that it takes actually 1 minute, it means that those cycles will start to overlap with each other. And this will create an endless spiral of growing demand for capacity, which will bring the performance of the environment down very, very quickly. So if you have multiple DAGs, you may need to increase this interval to a higher value, for example, 300, and therefore give more time to scheduler so that it can process all of your DAGs without the risk of overlapping processing of DAGs. The downside, obviously, is slightly lower responsiveness to DAG changes, but in production environments, it probably wouldn't happen that frequently anyway. And again, I'm calling it out specifically because I've seen this specific parameter to be misconfigured in multiple environments. In terms of don'ts, there are two things I'd like to call out that if you don't do, you're going to put yourself in a slightly better position from supportability or stability perspective. So first of all, please do not modify any settings of Composer's GKE clusters, even though those clusters are available directly in your projects. And from an ownership perspective, they belong to you and you have a chance to modify their settings. The moment you do that, you make Composer unaware of those changes that you have just applied. Therefore, any updates or upgrades that Composer would perform on those clusters would overwrite your settings or could lead to any other instabilities of your environment. In other words, if you avoid modifications of your GKE clusters of Composer environments, you put yourself in a much better position from supportability, reliability, and stability perspective. And one last item I would like to call out here is to avoid direct database querying, specifically for modifications of tasks, but also for reading. The right way to interact with Airflow elements is through the API. So either go through Airflow REST API or Airflow CLI. And if you need to, for example, mark a specific task as completed, you can always do those through one of those supported API layers rather than interacting directly with the database. The reason I'm calling it out is that's another item that, if done improperly, could cause stability issues or actually make the entire environment unusable. So again, please try avoiding that and switch, if you're using it, switch to using proper API layers of Airflow rather than those. With that, I wanted to thank you for attention and let me know in the comments below if you have any other suggestions or best practices you're looking forward to hear from us. And we can record another video on those as well. Thank you very much. Goodbye.